Now let's do some slightly larger molecules, or in some cases, formula units. So we've got C6H12O6, which is glucose. We see that there are three different elements. We need to set up three different parts to this. We have carbon, we have hydrogen, and we have oxygen. Let's set it up for the carbon part first, and then we'll move along for each element. There are 6 carbon atoms, so we're going to 6 times carbon's number. We're going to add to that, and now we've got hydrogen. There are 12 of them, so 12 times hydrogen's number. Add to that, and now we've got another 6 for oxygen. That's a lot of different atoms in a molecule of glucose, which means it's probably going to have a decently large molar mass. Let's see what numbers we would fill out. For carbon, we still are going to use 12.01. So we can put 12.01. For hydrogen, it's still roughly 1. It's 1.01. And for oxygen, I just haven't memorized, and trust me, you will learn some of these just by heart. Oxygen's is about 16.00. When you do all of them and you add them all up, you're going to get roughly 180 grams per mole. Pretty large in terms of weight, a molecule. Now we have MgClO32. When you have parentheses and there's a number outside those parentheses, you do need to distribute. So first thing we're going to do for this one is we need to actually figure out what are those different elements. So we've got magnesium. There's just one magnesium, so 1 Mg. Then we've got chlorine, but notice how there's a 2 outside this package, so we actually need to distribute that. So it's not just one chlorine, it's actually 2 chlorines, so 2 Cl atoms. And then we also have oxygen. There's not just 3 oxygens, there's 2 times 3, which is 6. So there's 6 oxygens. Pause the video and verify if these make sense. 1 times magnesium's average atomic mass, 2 times chlorine's average atomic mass, and 6 times oxygen's average atomic mass, because remember, we have to distribute that 2 to the 3 oxygens and the 1 chlorine inside that package. Altogether, you're going to get a molar mass of approximately 191.2 grams per mole for magnesium chlorate. And now we have ammonium sulfate. There's 4 different atoms here. You have nitrogen, you have hydrogen, you have sulfur, and you have oxygen. Let's set it up to see and verify what the molar mass calculation will be. Now, I set it up, but I intentionally made a mistake because this is a common mistake that I see a lot of people make. So let's take a look at this one by one and see what mistake exists. We see the formula here is NH42SO4. So you set it up, you're like, okay, there's 1 nitrogen, and there's 4 hydrogens, and there's 1 sulfur, and there's 4 oxygens based on these subscripts here. But there is a mistake. What is that mistake? Pause the video and see if you can figure it out. The mistake is there was a miscalculation in how I calculated the number of atoms for the nitrogen and the hydrogen, because remember, this 2 gets distributed. So it's not just 1, it's 2 nitrogen atoms. And it's not just 4, it's 8 hydrogen atoms. So make sure that your math checks out. At this point, though, you definitely have what it takes to fill these numbers in. You just look on the periodic table, find nitrogen, hydrogen, sulfur, and oxygen, so you know what those numbers are going to be. And you can do the math and you can figure out what is the molar mass of ammonium sulfate. That's how you calculate molar mass. Just watch out for pitfalls.